Okay, so today we're diving straight into something pretty big on the weather horizon. This forecast for a rare and early sudden stratospheric warming event, an SSW, possibly late 2025.
Right, and it's a big deal because it could really shake up winter across the Northern Hemisphere. We're
Yeah.
talking major volatility.
And the real kicker is this forecast, it basically flies in the face of the standard NOAA seasonal outlook, doesn't it?
It really does. You know, the NOAA baseline, the one most people see, it suggests maybe a milder winter, especially down south in the U.S. That's based on La Niña being around.
La Nina, right, the ocean signal.
Yeah, exactly, a long-term signal. So our mission here is to unpack how this powerful but shorter-term atmospheric thing, the SSW, could potentially just override that ocean signal for a while,
Yeah.
and what that actually means for the weather you experience.
Okay, let's get into the mechanics then. We should probably start with the polar vortex. Or maybe vortices, there are two, right?
Yeah, that's a good place to start. Think of the stratospheric polar vortex. That's the really high one, way up, like 15 to 50 kilometers up. That's the main engine, sort of the cold storage unit.
The big lid on the Arctic freezer.
Exactly. Keeps the coldest air locked up. Then below it, you've got the tropospheric polar vortex. That's basically the jet stream, the thing that actually drives our day-to-day weather down here.
Got it. Engine high up, weather maker lower down. So what's the SSW do to that engine?
Well, the SSW is when that stratospheric engine, that lid, kind of blows off. It's defined by this incredibly rapid temperature jump way up high, like it can warm up by 50 degrees Celsius, sometimes in just a few days.
50 degrees? Wow. What causes that?
It's caused by these huge atmospheric waves. We call them planetary waves. Think of them as big ripples in the atmosphere that surge upwards from way down near the surface when they break high up in the stratosphere.
Like waves breaking on a beach?
Sort of, yeah. That breaking action deposits energy, warms things up dramatically, and that disrupts the vortex. It weakens it, or sometimes even makes it reverse direction.
And when that high up vortex weakens, that affects the jet stream down below.
Absolutely, that's the crucial link. The weakening high up forces the tropospheric jet stream, our weather maker, to become really wavy and meandering. Instead of flowing strong west to east, it gets these big north-south dips and ridges.
That wavy pattern. Meridional flow, you call them.
Meridional flow, right. And that waviness is the only way you get those really prolonged, severe Arctic outbreaks spilling way south into places that don't normally see that kind of cold. Like, remember the Texas freeze in 2021? That was linked to this kind of pattern following an SSW.
Okay, but this forecast, it's for November. You said these are rare then, right? Like maybe only one major one on record that early, so why the confidence this year?
That's the really fascinating part. The confidence comes from what looks like a perfect storm setup of background climate signals.
Yep.
Two big ones known to sort of prime the atmosphere for an SSW.
Okay, what are they?
First, there's the QBO. The Quasi-Biennial Oscillation. It's this weird wind pattern high over the tropics that flips direction every couple of years. Right now, it's forecast to be in its easterly phase, or E-QBO.
And easterly QBO is bad for the vortex.
Bad for vortex stability,
Right.
yes. It makes it more susceptible to disruption from those planetary waves we talked about.
Right.
So E-QBO is factor one.
Okay, what's factor two?
Factor two is ENSO El Niño Southern Oscillation. We're heading into a La Niña phase. Probably a weak one, but still La Niña.
So E-QBO and La Nina together.
Exactly. And when you look back at the historical data, that specific combination, E-QBO plus La Niña, statistically points towards a higher likelihood of a weaker, more disruptible polar vortex during the winter. It's like the atmosphere's precondition for an SSW.
So the background conditions are lining up, making this rare early event more plausible.
Much more plausible than in a typical year, yes.
Okay, let's bring it back to the forecast conflict then. NOAA says, based on La Nina, likely warm south, cold north over the whole 90-day season. How does a potential SSW change that picture?
Right, the SSW acts like a powerful temporary override switch. When it happens and connects down to the lower atmosphere, which isn't guaranteed, but happens about 2/3 of the time.
Next down, there's a lag.
Yeah, there's usually a lag, maybe 1 to 3 months, for the effects to propagate downward from the stratosphere to really impact the jet stream. But if it couples, it tends to trigger a strong negative phase of something called the Arctic Oscillation, or AO.
Negative AO. That means cold for us.
Generally, yes. A negative AO means high pressure blocking near the pole, which allows that wavy jet stream pattern to set up and persist, delivering cold air southwards. It's a stronger signal than La Niña, but typically only dominates for shorter periods, maybe 2 to 6 weeks at a time.
Ah, okay. So the La Nina influences the whole season's average, but an SSW can cause these intense, weeks-long cold snaps that kind of overwhelm that average temporarily.
Precisely. So the main risk isn't necessarily a continuously frigid winter everywhere. It's more about the season being punctuated by one, maybe even more than one, really severe, prolonged cold outbreak that the seasonal average might totally hide.
Right. So the key takeaway for you listening should really be about preparing for volatility. Don't let a mild seasonal forecast lull you into thinking severe cold isn't possible.
Exactly. That's the strategic implication. So what you need to watch for are three things. First, confirmation the SSW actually happens.
Yeah.
We look for stratospheric winds to reverse.
Okay, step 1, SSW confirmed.
Step 2, watch for the coupling. Does that signal make it down to the troposphere? That's that 2 in 3 chance.
Right. Will it actually impact the jet stream?
And step 3, where does the blocking high pressure set up? If it's near Greenland, that often means colds for the eastern U.S. If it's more over Scandinavia, that can set up the beast from the east pattern for Europe. Location matters.
Confirmation, coupling, and location. Got it.
And just one final thought to leave you with. An early SSW, like the one potentially forecast, sometimes it doesn't just deliver one cold period and done. It can actually sort of prime the atmosphere, make it more unstable, potentially setting the stage for more disruptions later in the winter or even into early 2026.
A doubleheader winter scenario.
It's possible. This early volatility might just be the first punch, something definitely worth keeping an eye on.